I really want to mainly talk about the learning journey this we hope the students are having. Really to talk about the type of knowledge domain we're in, and the research journey is the focus, and to set a context for our two graduates speaking in a moment. We don't really need that much grammar, we'll skip that. I like this. This is a former tutor of mine, Paul Chenoweth. He was trying to map out what's the knowledge sphere of the built environment, and that's his sort of box, that it's in the social, creative, and applied domain. And I was trying to think, well, where are we as a program? So this is my own interpretation. That really, I think we live as applied, and we're slightly to the applied sciences actually, because we're drawing a little bit from the natural sciences, particularly building physics. So that's where I think we live. We're very, and the research you see the students are producing is applied, and it's strongly related in the scientific field. So that's what I would call our knowledge domain. And this is my summary of the program for the first 2 years, and you'll see that modelling is very much at the heart of it. So we have our year one energy modelling, PHP and deep, PHPP and deep, and then we have fabric modelling, thermal U value and linear thermal bridge, and then moisture analysis. And then in year two, the modelling is expanding out to, again, energy modelling, SBEM, and dynamic equivalent, and that dynamic is doing energy, thermal, and daylight. And then we're bringing in environmental assessment. So those of you that had an earlier iteration of year two, it is changing, and so it's really about building environmental assessment methods, and then life cycle methods related to the environment, circularity, and cost. So we're doing a lot of modelling. Theoretically, we're doing modelling. I think we should be getting better at maybe into even in bringing across the program that a deeper understanding of modelling. So we're doing a lot of assessment. We're doing a lot of modelling over year one and two, and we're applying them in case studies. And then you'll see that even the research the students are moving into is very applied. There's a lot of case study, because case study is an advanced research method if it's done right. So even in year three, we're very case study applied focused. So I hope that's just to give you a picture of the type of knowledge and the deep amount of modelling we're doing. We're using a whole diversity of modelling, and I think that's quite interesting. And we do need to almost have an underpinning modelling theory, understanding of models in general. I'm trying to emphasize that across mine. The one in yellow here is the one I want to talk about. So there's year one, policy and technology, the domestic energy analysis tools, the thermal and the moisture. And then we've added in last year for the first time a mini project, which is a type of research really. The students are given questions to answer, and I know they're not investigating third party literature, but they are investigating questions of how do I achieve NZ in a particular case. And what we've done, instead of giving the students the case, we let them choose. And that's proved great for a number of reasons. One is some students are modelling their own home or their granny's apartment or whatever it is. But a lot of them are also taking stuff off the drawing board that's current, and they're getting they're able to apply it immediately. So I think that's been really helpful. And plus we're getting a huge diversity of building stock being modelled. So you need 25 cases being modelled every year, and the students are learning from each other, a whole diversity of constructions, diversity of problems. And then we set them a problem to investigate. We give them options. I don't know how it is this year, but that's what we did last year. The options were compare plastic and natural insulations in a wall retrofit, or cold roof, warm roof, which is the best way to do this. So, and then they apply all these tools to answer those questions. So actually, we're introducing a small scale research in year one. So that's why I put it in yellow. It is research actually. It's not advanced research, but it is investigative application of the tools to answer particular questions in a case study example. And the first year we did it last year, Daniel is leading it this year. I found it brilliant, and the students that did it found it really helpful. And then we're expanding the research dimension in year one. It's basically half the year. It's half the year now. So the students are introduced to these new modeling, which is environmental modeling and then energy modeling, and that's much more sophisticated. And then they apply that and this in a half a year case study. So what you saw Siobhan present there was half a year's work, which is why it was so significant. You could see. But and again, the first year we did it, we gave them a case study, and this year we've let all the students choose case studies, and that's been really interesting because we've a huge diversity of cases, and people are taking projects off their board or previous projects they've worked on that have a common problem that they want to resolve, and they're drawn back from that. So I think it makes it much more applied to the students' own practice, and it makes it much more diverse, and the students again are learning from each other. And they're set in an overall research question. It is research really, and we split it in two. So the question they're set there is it possible to achieve net zero energy in a particular case? And in some cases it hasn't been, and in other cases it has been, taking into account optimizing it environmentally and from a circularity perspective. And from what I'm reading, I think it's fair to say that there's very little written on the holistic application of those three phenomena. I tried to do those two in my own net zero house, and that was a challenge. But trying to also introduce circularity really changes the whole game. So they apply that, and then out of that study this year, the students are taking an area of interest and researching a smaller 6-week question that they have. And we let them propose that, and if it's of a sufficient standard, we say go for it, investigate that. So we have students looking at all three in their investigation, and we some students just looking at the circularity aspect. I really want to go deeper into the circularity and explore this alternative facade, and we let them run with that. And that's piloted last year, and this is the second year on it. And again, it's producing really interesting and complex work. It's actually very complex what the students are researching there. And then the research element, of course, in year 3, it's a research year, and this is advanced research where the students are proposing the research question that's at leading edge in the field. So in order to set that they need to go into the literature around the interest area or the field or the area of exploration and go quite deep into that literature and say, how has that been explored by others? What are the common issues or problems? What are the methodologies they've used to propose that? And I'm going to build upon that by adapting and editing and integrate my research in. So it's advanced level 9 research, and you're going to see the guys present on that. They do a module on research methodology and another module on research studies where they begin to propose, I leave that second one and the third one, they begin to propose and develop a research project. They design their research project. And that's basically semester 1, and then in semester 2 they start into their actual research where they're given a supervisor. So that's the structure of the year. So that I consider them the theoretical skill base, and then we're applying an increasing level of case study emphasis and applied research across the 3 years. That's the way I've been proposing we adapt and develop the program. That there is research now across all 3 years, and it's scaling upwards. Hopefully, that's the concept anyway. So year 1, you've seen people doing quite significant case study analysis, both holistic building energy analysis using DEEP and now PHPP, and then it's a significant investigation into answering a fabric question that's set for them, that requires analytical and critical thinking and proper use of the tools. And they are being graded, not just, oh, you can use the tool, that's great. No, can you use it critically? Are you making the right informed decisions at the use of that tool? That type of thing. It is excellent work the students are producing. And then in year 2, as you've seen, case study, energy, environmental circularity, how do we make this more circular? Students proposing. This is a temporary works. The temporary works for the building works that remains in place, and can then be taken down. That all sorts of concepts being proposed. Computational fluid dynamics being investigated. Just fantastic work in year 2. I think year 2 is really is a great year, and at the integration of energy, environmental, and circular and life cycle thinking, I think is quite unique. Just to give you a picture of some of the things the students are producing. But the focus then really moves to year 3, which is about the development of advanced knowledge. So you've got to be asking a question that is slightly new and is not developing new knowledge in some sort of eureka way, but is building on existing knowledge. So it's very much something that is drawing from your practice experience and your applied knowledge and your skill set, but into the literature, into the existing body of literature that's out there. So there's quite a significant emphasis on engagement with the existing knowledge and adapting your understanding, proposing your research to build into that. So it's basically, there's me on the right, on the left there, and there's the student group. And we're saying, right, we're going to go into this area of advanced research. And as you go in, you're going to specialize somewhere, and we're going to give you a mentor, but it's your dive, it's your research, it's your exploration. We're just there to guide you. We've given you the equipment and the tools. Now take that deep dive into an area of knowledge, really pursue it and advance it. And often because of where we are in the applied science domain, most students are taking some sort of case study analysis and application. So they're looking at a particular thing, a particular building with different research methodologies and tools to answer a particular question, which we'll see later on. And we've had previous iterations of this when it was digital analysis and energy retrofit. I think we had 12 master's graduates through that over the 2 years that we got to run the masters that time. But this is the first new cohort that have come through the full MSc Building Performance EED, and these are their graphic posters. So I'll show you some of the questions. So we have a study that we presented in a while on hydrothermal risk assessment to do with application of EWI in Irish constructions. We've life cycle assessment you're going to see in a moment as well, of basically asking that question, fundamental question: do we demolish or and rebuild, or should we demolish, retain, and retrofit from both an energy and environmental perspective over a lifetime? So this is a very sophisticated and complex question, and you can see our students are able to answer that, and these are publishable, and we're encouraging these students to publish. We have an investigation of how we're ventilating in our schools, and that threw up all sorts of things about carbon levels and carbon assessment control strategies in schools and their inefficiency. We're fundamentally asking the question: are we doing it right, or should is natural ventilation, which is sort of mandated, achieving it, and are there other alternatives like mechanical, or will they do it better? So quite a sophisticated study, and this is again life cycle assessment, asking questions about what type of strategies, what type of materials are optimal for retrofit over a lifetime, so a lifetime perspective. They were the 4 graduates from last year, and we've how many's in year 3 at the moment? 4. We've 3 regularly, and we've 1 rejoin. So we've another 4 currently on the go, which is great. So I'm going to pass over now to I have to say my colleagues now, because we're master's graduates. I'm a master's graduate. We see them as peers. They're more specialists than I am in their fields. Okay, they are. I haven't done that depth of work. So, but really, I think they've taken tacit knowledge that they have in experience, in case experience, knowledge and skills that they've gained in the program, and done quite significant investigative research connected with the existing body of knowledge that's out there already in their project areas. Thank you so much.